All right, let's talk about what's called expected value. By expected value, one way you can think of this is this way. Let's say, and we'll do this one here in just a second, but let's say I was going to roll a die 1,000 times. I didn't have much to do that day, okay? But what the expected value tells you is what value you would expect to average if you did that a lot of times. That's what expected value is. It's without having to actually roll the die 1,000 times, it will tell you what you would expect to average if you rolled the die, in my example, 1,000, 10,000 times, okay? What you expect to average. So that's what expected value is. It's a long haul average. It's kind of the little expression for it. That's what it basically, it's what you would average if you went over the long haul, rolled the die thousands of times or whatever. We'll talk about this in the context of games. It's what you'd expect to average if you played the game so many times. Okay? Here's how you do it, though, to calculate it. Like I said, we're not actually going to roll the die 1,000 times. We're just going to calculate this based on some calculations here. The expected value, the way you calculate it, expected value is calculated by multiplying all the x, going back to the probability distribution now, you multiply all the x's by their p of x's and add them together. Here's what I mean by that. For example, if I have x and p of x, that's my example. I want, well, let's just, it was 1, what was it, 1 and 1/4, 2 and 1/4, and 3 and 1/2. Remember that? I did that example, probability distribution. So the expected value is calculated by multiplying all the x by their p of x's from this probability distribution and add those together. So here's what that means. Expected value for this one we're going to, for obvious reasons, hopefully anyway, we're going to denote expected value as e parentheses x, expected value. What I'm going to do is I'm going to take each x and multiply it by its p of x. So I'm going to do 1 times 1/4 plus 2 times its p of x, 1/4, and then 3 times its p of x, 1/2. So what that will give me, that'll give me, well, that being 1 over 1 would be 1/4. That'll be 2 over 1, so that'll be 2/4, and that'll be 3 over 1, so it'll be 3/2. If we add those together, here's what I get. 1/4 plus 2/4. Oh, and this one needs to be fourths, doesn't it? So that would be 6/4. Be 9/4. If I just get a common denominator there. See what I did there? You don't have to do this, but I just multiplied that by 2 and that by 2. So it's 6/4, that's 9/4. That's my expected value. That's how I do it. Multiply each x, get your probability distribution and multiply each x times p of x. It's called the expected value. Okay? So let's do a couple of these from, I gave you the probability distribution there, so let me do these from, a couple of these from scratch. Well, let's do the rolling of the die problem here. What is the expected value when rolling a die? What is the expected value when rolling a die? Like I said, we're starting this one from scratch, so if the expected value, I multiply each x by p of x, wouldn't it stand to reason here I want to start with, first of all, we need to do the probability distribution. So we want to do our x, and that was just that table of x and p of x values. This one was a pretty easy one, right? For the x, I just do all the possible values. When I'm rolling a die, what are the possible values? 1 through 6. And then what's the probability of 1? 1/6. What's the probability of 2? 1/6. Yeah, same all the way down. Okay. All these are 1/6. Okay? However, I want to know the expected value, so step 2 is, do your expected value here. How do I do the expected value? E of x. Well, you multiply each x by p of x. I'm going to multiply 1 times 1/6, 2 times 1/6, 3 times 1/6, 4 times 1/6, so on and so forth. Just multiply each one all the way down and add them together. What does that give me? Well, 1 times 1/6 is 1/6. 2 times 1/6, and I'm going to go ahead and not reduce it, that would be 2 over 6, wouldn't it? 3 times 1/6 would be 3/6, 4/6, 5/6, and 6/6. With me on that? I just multiplied because those are over 1. You multiply them, so you multiply. This one would be 3 times 1 over 1 times 6, so it's 3/6. 4 times 1 over 1 times. Okay? And now we add them, so that's why I didn't reduce them, because they all now have common denominators. So what do we got? 12, 20, 27/6, which that reduces to be by 3, be 9 halves. But let me go ahead and put this as a decimal. What is 9 halves as a decimal? Did I mess up?
No, I don't know.
I think I did, because that's not right. 21 out of 6. 6, 10, yeah, 21 over 6. I don't know how I got 27. I think I added something twice. I don't know. But anyway, 21 over 6, which reduces to be 7 halves, which as a decimal is 3.5. Yeah, that sounds more right. Okay. 21 over 6, which is 7 halves, but let's take it to 3.5. Now, expected value is 3.5. Notice one thing about it is that's bigger than 1. This isn't a probability. This is not a probability. Expected value is not a probability. So it can be bigger than 1. It can be negative. It can be between 0 and 1, but it's not a probability, so this is okay. This is okay. You can't have expected values bigger than 1. You can have negative. What this means is this is what we would expect to average if we rolled the die 1,000 times, 10,000 times. That's what we would average. The average of our rolls. Which makes sense, doesn't it? Because if I roll it 1,000 times, I'm going to, if it's a fair die, anyway, I'm going to expect to get most of these about the same amount of times. So that would mean, yeah, the average is going to be somewhere right in the middle, which is 3.5. So that one, that's what it means. Okay. Let's try another one. Let's say I do this. We'll do games a lot on these, so let me get to those. All right, say 2 coins are flipped. We win $5 if both are heads. We lose $2 if they are not both heads. What is the expected value of the winnings? What is the expected value of the winnings? Or shortened, what are the expected winnings? Okay, but it's the expected value of the winnings. Okay. All right, well, what's our first step? Our little table, probability distribution. Now, if we're talking about a game, my suggestion to you is for your x, let x be the winnings or losings. Okay. What are the possible winnings here? Well, I could win $5. So that's one of my x's. What else is an x? I could lose $2. So what do you want me to put for that? A -2? Yeah. So here, x is the winnings, possible winnings. Okay. Now I need to know probabilities. What is the probability that I win $5? Well, the probability I win $5 is the probability that I do that, right? Both heads? What's the probability that it's both heads? Well, again, if you want to write it out, heads, 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 tails, tails, heads, tails, tails. So what's this probability? Well, it's the probability both are heads, 1/4. What's the probability I lose $2? Well, it's the probability that I don't get both heads. 3/4. Yeah. With me? 5 is 1/4, -2 is 3/4 probability. Because this is the probability I don't get both heads. 3 of them. I would lose $2 here, here, and here, right? So 3 out of 4 times I'm going to lose $2. Okay, but that's not the question. The question was, what's the expected value of the winnings? So how do I do that? Well, once I get the table, just multiply 5 times 1/4. Then multiply -2 times 3/4. See what I get. That would be 5/4 plus -2 times 3/4 be -6/4. What's that going to give you? -1/4. That's what I was saying. Expected value, you can get negative values. Here we do. Okay, yeah, what does this mean? This is the expected value of the winnings. This would be the expected winnings we would expect to have if we played this game a lot. we would expect to average losing 1/4, or $0.25. Negative $0.25. We lost $2, we win $5. But this is what we'd expect to average, which brings up another point. Yeah, this number, am I ever going to lose a quarter? No. I lose $2 or I win $5. But this is an average, right? Your average doesn't have to be one of these numbers. It won't be one of these numbers usually. Yeah, this is what we expect to average. Like if I played it 50 times, I would expect to average losing 25 cents each time. I'm not going to lose 25 cents ever, but on average, that's what I would. So I would expect to lose that much per time on average. Okay? So it's a little different, but that's what it means.